All right. So as some of you are finishing with your notes, right? Is everyone ready? What did we learn last time? Something with parabolas, right?
We learned about the vertex of
Yes. Thank you. Okay, and I will take the totally looking at your notes. Yep, so we learned about vertex form of a quadratic equation, right? And we learned how the different parts of the equation affect the parabola, right? Who remembers if A is negative, what happens to the parabola? Do you guys remember if A is negative? If the number in front of the parentheses is negative, do you guys remember what happens? Goes down. Yes, so it flips the parabola down. Good. And which part of the equation is the opposite sign? Do you guys remember which part is the opposite sign? Nobody remembers this? You can. Yeah, the number in the parentheses, right? Which is the H value. Okay, that is always the opposite sign. Okay. So what we're going to learn today is we are going to continue using vertex form. All right, so we're going to be experts at it. Plus, we're going to talk about some more. Everyone listening? We are going to talk about some more characteristics. Sorry, that was the word I was thinking of. More characteristics about a parabola. Okay? So first things first. All right, the parent function. Remember the parent function, it's like the OG one, is just x squared, right? It's just y equals x squared. And the vertex is at 0, 0, right? So we're going to plot that point. And then it just opens up, right? Something like this. So that's the parent function, right? Without any transformations or anything happening to it. All right, so when we learned about vertex form, all right, so let's talk about the A value first. All right, so if A is not equal to 1, so if it's any number other than 1, the graph is stretched. That's our blank right there. So it's stretched, right? Which means stretched vertically, which means it's going to be more narrow, right? Or it's shrunk, which means it's going to be wider, or it's reflected, right? So that's how A affects our parabola. All right. What is H? What type of translation does it do? Which left or right? What's left or right? Which horizontal, right? So it's going to be the horizontal. So we're going to look left to right. All right. And I put a little hint here. Okay, because this actually applies to all function types. So if you take secondary math 3 next year, you're going to learn about other function types like square root, rational, anyway, a bunch of other types of functions. If there's a plus or minus in the operation symbol, which here it's the parentheses that are being squared, if there's something happening in the operation, it's always opposite sign. So the saying that I like to say is, if it lies inside their operation, it's lying to you, right? It's the opposite sign. So H is always lying to us. All right. Now, what does K do? It's a vertical translation, right? So this number shifts the parabola up or down. And we saw last time when we did our practice, sometimes they put K in front, right? So we just have to make sure we look at the equation carefully. Okay, and the vertex is at what? Something, something. Looking for 2 letters. H and K. right? So if we're using this vertex form, if we're looking at that, the vertex is always going to be h comma k. All right, and the axis of symmetry, we're going to talk about that in a minute, is always x equals h. So maybe you want to highlight this, bold it, put a box around it like I am, okay? So the axis of symmetry will always be x equals h. And we'll talk about that very shortly. Okay, let's mention some other things that we know about parabolas, okay? So we know the vertex is either the highest point or the lowest point, right? It just depends on where the parabola is, if it's opened up or if it's opened down, okay? And then, do you remember yesterday when last class, when I showed you the parabola, I mentioned if it was a paper and you folded it over, it would fold onto itself, right? So all parabolas are symmetric. That's our first blank right here. Right? So whatever the parabola looks like, it's always symmetric with itself. And so there's this invisible vertical line going through the middle. Oh, my line's not very good. But anyhow, and we call that the line of symmetry. It's basically the line that you would fold so that it folds onto itself. Okay? And we know the vertex is the point right in the what of the parabola? Middle. Good job. It's right in the middle of the parabola. And there is always a vertical line. So the axis of symmetry is vertical line, and that's what splits it in half. And remember, it's x equals h, okay? Anyway. All right, some other thing, domain. So the x values of a parabola, most of them have a domain of all real numbers or negative infinity to infinity. Most of them do, unless it's restricted. That's the next blank. So some have a restricted domain. Do you guys remember the problem with the area of the garden that we did on the review assignment? Right? And he only had 16 feet of fencing. Do you remember that? Steve or whatever it was. Okay. That was an example. Since we're applying that information, there was only so many values that x could be, right? So that happens when we do application problems. Okay. All right. The range or the y values, that depends on how the parabola shifted up and down. Okay. But the range should never be negative infinity to infinity, because we are dealing with parabolas that are opened up or that are opened down. All right. So the range will never be negative infinity to infinity. So that's an important note to remember. Okay. All right. And then the minimum or maximum. This is the highest or lowest point of the parabola. All right, so if it's the highest point, that means it's a maximum. It's a maximum height. If it's the lowest point, that means it's the minimum. Okay, the last thing about parabolas are zeros. Okay, this is where the graph crosses or touches the x-axis. And they are also referred to as the solutions. So when we get to Unit 3, we're going to start solving quadratic equations. And so then we will talk more about that in Unit 3, okay? All right, so we have these characteristics of parabolas. So let's kind of apply this knowledge here and look at the first example that we have. All right? So number one, first thing we want to find or identify is the what? Vertex, right? And where's the vertex on the parabola? Wake up. Hello. Where is the vertex on this one? It's right here at the bottom, right? Okay, so right now it's the minimum point. It's the lowest point. And that coordinate is what? Looks like -3, -4. All right, 1, 2, 3, 1, 2, 3, 4, right? So we know the vertex is -3, -4. We know the domain. Is this parabola going to keep going forever to the left and forever to the right? Yes. So the domain is going to be -infinity to infinity. And now the range. Yeah, so the lowest y value that this parabola touches is that -4, right? So it goes from -4 up. So that's why we want to put -4 first with a bracket. Why am I using a bracket again? Because and it actually touches -4, right? Yeah. Yeah, so -4 to infinity. All right. Okay, and now the axis of symmetry. Okay, this is always a vertical line. So since it's a vertical line, it will always be x equals a number. Because x equals whatever is going to be a vertical line. So x equals what? What line is going to make that symmetric? Yep, x equals -3. Okay? All right, I'm going to give you guys a head start on number 2. Go ahead and find the vertex, domain range, and so forth. Okay, I just realized the coordinate grid is like, it's flipped. That's not confusing. Anyway. All right, can I have someone in group 7? So like Ashton's group. What did you guys get for the vertex? 0 what?
1, 2, 0, 2.
Yeah, it went up 2. Wait, no, 0, 1, because this is 2. This line is 2. Sorry, your copy is probably really, really small and you can't see it. But this line is 2, which means this would be 1. So it is 0, 1. Thank you. Okay. How about group 8? Can you guys help me with the domain? Morgan and Sean? Yep. It's -infinity to infinity, right? I must have done something when I took this snippet. You know, when I took a snippet of it, something must have happened. And I don't know what. The rest of them aren't like that, right? No, the rest of them aren't. Sorry about that. Okay, range. So in group 5, that's Rocky's group. Okay, so it goes -infinity because it will go down forever, right? So we'll always start with the lesser value. So -infinity has to go first. Then you said 1? Bracket or parenthesis? Bracket, because it touches that 1. All right, axis of symmetry, group 1, help me out. X equals what? What does x equal with this vertical line right here? 0. X equals 0. Nice. Okay. Let's continue on with 3 and 4. So I'll give you a head start on both of those problems and then we will check them, okay? All right, let's see where we're at here. So on number 3, I got 4, 0 for the vertex, right? Domain is everything because it will keep going to the left and right. Okay, so let's go group 6. Will you guys help me with the range? What's the lowest y value it can touch? It's the lowest y value. That's the x coordinate. What's the y coordinate? 0, right? At that point? Yes, so the range is going to be 0 is the lowest value to, it goes forever up, right? So 0 to infinity. Okay, Thomas and Caleb, what's our axis of symmetry for this one? X equals what?
It's like the only one we didn't do.
So the axis of symmetry will always be x equals h. And remember, h is the x coordinate of the vertex. Yep, so it will be x equals 4. Perfect. All right, vertex on the next one. Tess and Hudson, do you guys have the vertex for this parabola?
5, -2.
Yep, so it went over 5. Guys, listen. It went down 2, right? So it'll be 5, -2. All right. Domain. What will be the domain, everybody? All real numbers. Yep. -infinity to infinity. Good. Let's go to group 4 over there. ADS group. Can you guys help me with the range? Does it go down forever? Yes. So then we're going to go -infinity. What's the highest y value it touches? -2 with a bracket. Good job. And then the axis of symmetry that makes it symmetric is x equals 5. Good job. Easy peasy. You guys did I not train you last time? When I say easy peasy, you say lemon squeezy. Thank you. Thank you, with your mouth full of Doritos. Okay. All right, let's move on to the last 2 problems here. So now we have the equation in vertex form. We're going to graph it. So here's our A value, right? Is that -1? What is our H? Hope everyone's listening. H is a +2, right? Because H is always lying to us. And then what is K? Nothing, which is 0. A is -1. Okay, so what is the vertex going to be? HK. So the vertex will be 2, right? Because we decided H is a +2. And K, which is 0. So now we can plot that vertex. And with that A being -1, we know the parabola is going to do what? It's going to be open downward. So something like that. And we also know the axis of symmetry will be x equals 2. Yep. Because it's always x equals h. Okay, so now I want you to identify A, H, and K on number 6. I'll give you a head start. Oh, do you need the notes from last time?
I don't know.
What?
Yeah, I don't know what to do.
I'm like, what? Oh. Okay. All right. I will get both of you guys the notes. That's what that's A, right? And what is that 1/3 going to do to the parabola? You guys remember? Make it wider. It's going to make it wider because it's between 0 and 1. Okay. Now, do we have an H? Is there something being added or subtracted in the parentheses? No. So what does that mean? H is 0, right? There's nothing in the parentheses, so H is 0. And then K is always the number not in the parentheses, right? So K will be 1. So then we know the vertex will be 0, 1 because it's HK. So we're going to plot 0, 1. Okay, and let's just make the 1/3 is just going to make it more wide. Maybe something like this. Right. And the axis of symmetry. So what makes it symmetric? X equals 0. Nice job. Questions? Okay,